Alright, ladies and gentlemen, here we go. We're going to do a little bit of review for the quiz tomorrow. On rational expressions, first we're going to look at a warm-up question, which is to reduce to lowest terms, and then we're going to go through some of the definitions. These are just from the notes that we did in class. I'm just kind of doing a comprehensive review of this. Alright, so we'll begin with the 14x squared over 2x. So, first way we could look at this is to break down all the pieces and see what will cancel. So we might start out by breaking down 14 as 2 times 7 and x squared as x times x. Next we would look at, really there's nothing to break down on the denominator end, so just 2 times x. Now focusing on the things that are in common, we have a pair of 2's common there, we have a pair of x's common there. So we could cancel those out because there's one on the top and one on the bottom. Anything divided by itself is always equal to 1, and that goes for variables as well. So what we have left over is that we have on the top we have a 7x, and on the bottom we have a 1. So you could just write this as 7x or 7x over 1. Okay, so the next one, we could maybe simplify before breaking things down and just focus maybe on the 3 over 6 here first. And so 3 and 6 are divisible by 3, and we're going to get a 1 on top and a 2 on the bottom. Now if there are 5 x's being multiplied in the numerator and 3 x's being multiplied in the denominator, then some of those are going to cancel. So for every 3 I have in the denominator, I will get rid of 3 in the numerator, and that's going to leave me with a power of 2, or 2 x's in the numerator left over. So I would write my answer here as x squared over 2. For some problems they look a little more complicated. You can sort of break them up into pieces. So for letter C here, 30x cubed y to the 5th divided by over 6x squared y to the 3rd. So I can group the sort of fractional parts, sort of like factoring this a little bit. I can write the 30 over 6 in one grouping with a set of parentheses. Another set of parentheses would emphasize the x variables, and the y variables as well would get its own fraction. And then we can concentrate on how many things would cancel. So if we look at 30 over 6, we know that 6 divides into 30 5 times. X squared divides into x cubed, leaving us with 1 power of x left over. And y cubed divides into y to the 5th, leaving us with a power of 2. If you remember, you're just subtracting the exponents there. So ultimately, our answer is 5x to the 1st, y to the 2nd, all over 1, because anytime any of these canceled, we're really getting a 1 in place of them. So 5xy squared, or 5xy squared over 1. Okay, so the definitions that we worked on are what is a rational expression. That is, a rational expression is just the ratio of 2 algebraic expressions like polynomials. And then what is an undefined fraction? An undefined fraction is one in which its denominator is equal to 0. I'll write that on top there. Denominator equal to 0. And that's exactly how we're going to find the x values, find the value of x, that makes a fraction undefined. So to be clear, any fraction has a numerator and a denominator, a numerator over denominator, and the denominator is never allowed to be equal to 0. So what we do is we set the denominator equal to 0 so that we can find out what the excluded values will be. Alright, so if we take a look at, let me switch colors here. So 6 over x plus 4, I'm not really interested in the numerator at the moment. I really want to focus on this denominator down here. Okay, so I'm going to set that equal to 0 and find the x values that will make that equal to 0. And that's just a simple subtraction I'll get x equals -4. And so I will get one value of x that is going to be excluded. So excluded means it's not allowed to be substituted in for x because it would make a denominator of 0, and a fraction with a denominator of 0 does not have a definition, so it's undefined. Setting the second problem here, denominator equal to 0, I could use either one of two methods to solve this equation. If you remember from quadratic equations, you could take the 9, add it to the other side, and use the square root method to solve the equation. So what squared is equal to 9 is going to be solved by taking the square root of both sides. So the square and the square root cancel each other out, and we're left over with x. And the square root of 9 is 3, but it could be positive 3 or it could be -3. That if you square either one of those, you'll get 9. So we get two answers when we take the square root of a number. Alright, so those would be the two numbers that are the excluded values. Alright, let's take a look at this next one, and again you can see where the factoring is really taking command over a lot of the stuff that we do with these rational functions. So I'm going to be interested in what makes the denominator here equal to 0. We're going to set x squared minus 5x minus 24 equal to 0. Now, solving a quadratic equation like this, we have some options. The quickest way to try is if you can factor the bottom part there. So into two factors, we do this little test where we set up a diagram with an x. All right, we put this number on the end here up top. That's the product number. And we put this number in the middle here, -5. That's the addition number, or the sum. So you take a product, two numbers, we're going to put in the other parts of this diagram, are going to multiply to -24 and add to -5. And so if we think about the factors of -24, well, they could be 6 and 4. But those don't have, those wouldn't work out. Now, first of all, the signs of the two numbers we're looking for, they must be different. One has to be positive and one has to be negative, because that's the only way if we multiply two numbers that we're going to get a -24. So one of them has to be positive, one of them has to be negative. Two numbers that multiply 24, and it doesn't look like it's going to be 6 and 4, because those two numbers would not add to -5. 8 and 3, however, now those two candidates work, and it would have to be a -8 and a +3 to multiply to give you -24 and add to -5. So that tells me these two numbers right here tell me what my factors are of this equation. It's going to tell me that's a factor of x plus 3 and a factor of x minus 8. Now here's the thing that we do when we solve a quadratic equation. Once we've factored it, we set up a little table that looks like a big T. And we set each one of the factors there equal to 0. So that's going to be the first factor here set equal to 0. So x plus 3 is equal to 0. And we solve that equation by subtracting the 3 to the other side. We get a little answer there. X equals -3. Then we take a look at the second factor here, x minus 8, and we set it equal to 0. And solving for that, we get x equals +8. So there are two values here that are excluded values from this because they will make the denominator of this equal to 0. And that's a no-no. So that's what finding the values that make the fraction undefined is all about. Set the denominator equal to 0 and find those x values. Alright, in the next part, we're going to examine how to simplify a rational expression through factoring and canceling.